That, by the way, that's amazing. So we're going to see how amazing that is. Can you guys remind me, to show evidence, is a higher p-value or a lower p-value more evidence? Which one? That's a really weird question, maybe. But a p-value means the probability of what you saw was due to random circumstances. You guys with me? So when is it going to be more likely that it actually is evidence of something real if the p-value is small? Because that means the probability it's just randomly happened is small. You guys with me? A smaller p-value is more evidence against the null hypothesis in favor of the high. That's what that is. That's what a p-value really is. And that's why they report p-values in articles about research they've done so that everybody can make up their own mind. If p is 0.04, some people will go, that's good, and other people will go, that's not good enough. Yes, no, maybe so? A p of 0.2 is shit. 20% chance it randomly happened. That's not evidence of anything. All right, let me stop for a second. What we're going to do then is we're going to take the results of 11 correct, and we're going to calculate what the p-value is. Normally, I in the past, I had somebody get 8 right. 11 is insane. And the fact that it happened 3 times over is equally, remarkably, insanely insane. So it's, so again, what's the claim? If we think that we have ESP, or we have whatever you want to call it, what's the claim that we're making? That we're going to perform better than random. So if you got 5 right, you got exactly the amount that would have expected if you were just guessing. Anybody get 0? I don't know. One person got 0 in my other class, so she was like the anti. I'm like, whatever you think somebody's thinking, just think the opposite and you're golden. All right. So where would that go?
In the high.
In the high, because it does not have a equal sign. What's the ho going to be? Less than or equal to. I like it. So how many tail tests would it be?
1.
Yeah, 1 tail. A 1 tail. This is normal. What do I check? Now you'll see why I said 25 times. NP, which we sort of already calculated, right? It's going to be 25 times 0.2, which is 5, which is at least 5. So if I would have done less than 25, it would not have been normal enough. And what's NQ? Point. No. 8. 0.8. That's right, kids. 20, and that's at least 5. You guys with me? That's the check to make sure that it's normal enough. What would the third step be? The third step would be setting up the rejection region. I'm going to skip that step. Because they didn't tell us alpha, did I? Because I'm a jackass. We're just going to go straight to the p-value. Okay. So let me give myself some more room. Skip you for a second. So using the results of 11, what's p hat? 3 people got 11 out of 25, correct. What's 11 divided by 25? 0.44. So they got just under half right, which is amazing. So then I can do my Z star. It's our data. What's our data? 0.44. No, it's p hat. That's what we got from our data, 0.44. Minus what p is, and we're assuming p to be 0.2, divided by square root 0.2 times 0.8 divided by n, which was 25. Okay, so help me out. Figure out what that is. You guys get 3? Maybe I should do 2. Yeah, 3. Whoa, Jeff, what did you do, buddy? Oh. 3? Holy shit, exactly 3. That's neat. There's so many neat things about this result. Can you please find the p-value for that? Sorry, Julie. Hold on just a second. Make sure everybody gets a chance. Try to figure out the p-value. All right. What do you guys get? Yeah, how'd you get that?
I found it on the z-score chart and subtracted it by 1.
Yes, cool. So when you look up 3 on the z-score chart, you get 0.9987. And then, you guys see that? And that's not in the tail, that's below 3, and then I need the amount that's in the tail, so it's going to be 0.0013. Is that small? Oh, hell yeah. Right? That would pass any test where alpha is at least that. So if alpha was 0.001, this wouldn't succeed, but 0.001 is an unheard of level of evidence required. I don't know if you guys are with me. See, step 3, we have to do when we're learning statistics, which we don't have an internal feel of what alpha should be. So they provide us with alpha. In the real world, when you are in nursing or business or psychology or whatever, and you're reading an article, you have your own internalized sense of what alpha is because you know a lot of shit. You don't currently know a lot of shit yet, right? You guys semi with me? So they have to give you alpha because we don't know how to figure out what alpha should be ourselves yet. So this is the way it works in real life. Step 3 is non-existent in real life. They just report what the p-value is. Now, every time you see, if I pulled up a study, they would say, we assumed our own level to be p less than 0.01 or something. But then somebody can disagree with that and say, no, I need p less than 0.005. Thank you very much. I really don't know if you guys get what I'm saying. So it's, if I try to prove something to you, if I try to prove to you that I could make every free throw I took, well, that's not a great example, because then the only way to do this is make every single one. If I try to prove to you that I could make more than half of my free throws, there would be different level of evidence for people. So I could take 10 free throws and make 6, and that might be good for somebody. But then somebody else is like, no, you got to take 20 free throws. And somebody else would be like, no, you got to take 50 free throws. You guys kind of with me? Do you guys understand that? If somebody says something like, prove that, every person would have their own feel of what enough evidence is. That's what alpha is. And whenever you get into your own field of study and you studied it far enough, and when you look at a statistical analysis related to that field you're in, you'll have a better feel of what alpha should be in that situation. Nobody's going to tell you what the shit it is. You're going to come up with your own. And you'll be able to interpret, is that good enough? So there was a prize that they stopped giving, I think it was 2008 or something. Well, not stopped giving, they never gave it. Somebody, there was a company that said, we'll give $1 million to anybody who can give concrete evidence of ESP. And this is one of the, they had a battery of tests. And I think a few people tried it, and not many people came forward, so they're like, screw it, we're done. We're not going to offer that anymore. Right, so if you actually have ESP, you missed your chance at $1 million, but if you have actually an ESP, you should be able to make money a lot of other ways, right? All right, I love you guys. You guys all right? You guys semi with me? I lost everyone. Y'all hate ESP now too? All right, let's check. So here, the conclusion, we wouldn't come up with a conclusion. We would express this in a study. Now, to be honest, this is why I would do this, but there's 3 people. I don't know if I want to try to do all 3, but if I had one person that had really good evidence they had ESP, I would retest them. And that's what science is all about, right? You don't normally write an article about something you see until you have another group independently verify what you saw. So what could have happened? Is it impossible for somebody to get 11 correct? No. Even if they don't have ESP, is it impossible for somebody to guess 11? Is it impossible for somebody to guess all of them correctly? No. Is it likely? No, hell no. So this is the whole thing about why people hate statistics. Stats can't tell you definitively what's true. It can just tell you what's more likely and what's less likely. That's all it can do. That's why I love it. It's so freaking truthful. That's life. Holy shit. All right. Any questions about what we just did? Do you guys have fun doing that? The three of you that gotta keep track of you guys now. I'm gonna start wearing my tinfoil hat so you can't see the answers as I'm making the key. Oh yeah. All right. Last thing I want to talk about, real quick. There's one section out of 10. I did discuss. Yeah, we talked about types of error last time, right? Nobody's asked me questions from the homework, so I guess that's going okay because I know everybody's doing homework. It's crazy. So last thing I want to talk about. Everything in chapter 9 is about one sample. Hypothesis test for one sample mean, hypothesis test for one sample proportion, all that kind of stuff. Let's go back to this example we've done before. How would I test if I created a new drug specifically to alleviate headaches caused by statistics? How would I test the claim that it's better than Tylenol?
You get the mean for Tylenol. How fast?
Yep, okay. But how could I test it if I don't know that? Huh?
I said take it.
Take what? Oh, take it. Sure, I can take Tylenol, but that's just a sample of one. Is that good enough? So what would I do? I would take a sample of people and give them... Huh? I could take a sample of people and give them Tylenol. Take a sample of people and give them my new drug. You with me? Like, well, first subjective statistics. Right? Give them all a headache. Give one group Tylenol and give the other group my new drug. Are you with me? In that case, what are my results going to be? How many sample means will I get? Two, because I'm going to have two samples. I'm going to have a sample that got Tylenol and a sample that got my new drug. And I love how I can see some of you guys are developing headaches right now as I speak. I'm sorry. It's just, well, it's part of my job. I got an A++ in causing headaches. So in chapter 10, we get even a little closer to real life. Or, not saying that chapter 9 is never useful, but chapter 10 is closer to what we actually have to do for most things. I'm going to have two samples, and then I'm going to try to see how different are those two samples from each other. So what's going to happen here, Z star for means was this. Right? And you're all like, well, yes, Jeff, it was. And let me write this a little more spelled out here. This was this, right? Yes, Jeff. Yes, it was. Okay. And then I'm going to go even one more insane freaking step. The square root of what is sigma? What do I take the square root of to get sigma? Well, the square root of what is sigma? So like the square root of what is 3? What's the square root of what is 3? 9. I love it. So the square root of what is sigma? Sigma squared. So can't I rewrite this as this? And I know you don't understand why I did that, but can I? Can I just do it? Because I like math and I like playing around with math. I'm like, look at what I'm doing. It's exactly what I say when I'm playing with math. Look at what I do. What's the square root of sigma squared? Sigma. What's the square root of n? Square root of n. Hey, so they're the same. That's all I'm saying. So right now you're like, sure, math boy, you can do that, whatever you want. All right, so here's why I did that. This is what's kind of nifty, if you let it be. Can you see how there's only one sample in here? And actually, let me make this even a little bit. Let me do one thing. And you're all like, just do it, dude. Let's make this a little more real life. Let's make it a T-score. So this should just be an S. You guys with me? That's the one change I'll make. That's just an S. There, even a little bit better. It would have worked the other way too, but I just want to make it purely sample information. So, can you see how there's only one sample? One mean, one standard deviation, one log. Okay. So watch. This one, everything doubles. And that's it. The formula actually doesn't, it's kind of weird. So watch. In this case, T star would be X bar 1 minus mu 1. Oh, I can see you guys already like this. Okay. Minus X bar 2 minus mu 2 all over. You see how it just doubled everything? There's two sample means. There's two. What would the two populations be for this? The population of everybody who takes Tylenol and the population of everybody who takes my drug. That's the two mu's. X bar would be what I see in my sample for the Tylenol. X bar 2 would be what I see in my sample for my drug. Divided by big S square root. So now I'm going to have two S's, S1 and N1 for my Tylenol people, and S2 and N2 for my drug people. Holy shit. I know that formula is not what you would consider pretty, anywhere near. You already didn't like this one, but now you're like, oh God. But do you see how there was one X bar, now there's two, of course. There was one mu, now there's two, of course. There was one S, now there's two. There's one N, now there's two. I mean, because I got two samples I'm talking about, so now there's got to be two of everything in there. Same idea. The idea of the formula did not change. But the amount of stuff I got doubled. And here's what normally happens. Oh man, do I want to write all this stuff? Sure, Jeff. Come on, you'll make it, dude. All right. Got it. You guys see that math I just did? The weird ass. I don't know if you guys see that. Trust me, if you reorganize this, you'll come out with that. X bar 1 minus X bar 2. Minus mu 1 minus mu 2. All right, and if you don't trust me, you can try it yourself, or you can just sit there and it's your job to know math, boy. All right. Now listen. If I'm testing my drug to show that it's different from Tylenol, what am I fighting against? Somebody who would come up and say, your drug is the same as Tylenol. You guys with me? I'm trying to show it's different, it's better, and somebody would go, that's the same shit, dude. What are you talking about? You guys understand what I'm saying? So I'm fighting against the idea that the mean of everybody who takes Tylenol would be the same as the mean of everybody who takes my drug. I'm fighting against that. So H naught would be that the two means equal each other, which means this would be 0. So then my formula just becomes these divided by this business. And what I love about that is, at least visually, it becomes how different are the two samples. And that really should be what it's about. If I give this drug to these guys and the other drug to those guys, how different are they? Are they different enough to show that there is a true difference for everybody who would take those drugs? So that's what the top says. How different are the two samples from each other? This one minus that one, divided by the spread, tells me how relatively different. I would interpret it the same way. If I got a T star of 3, That's probably evidence. That's bigger than most of the critical ones we use, right? Whereas if I got a T-star of 1, that's probably not going to beat any test I do. Okay, maybe. Because what's the normal stuff? 1.645 for z-scores, 1.96, 2.33, stuff like that. That's normal. All right. So this would be the step 4. This would be how step 4 would change, is I would use this formula. I didn't want to say this before I started about this, but I'll say this now to alleviate your fears. I'm going to make section 10, whatever it was I signed, extra credit. 10.2, whatever, I can't remember what section it was. I signed one section out of chapter 10. I'm going to make it extra credit. So if you didn't like anything I just said, you can just forget about it, I guess. Yes?
So the formula we use, we don't use minus.
Because the ones that I signed will have this as the null, that they could be equal to each other. And if they're and if I assume they're equal to each other, this part is 0. Is that always true in real life? No, but that's kind of like the first step you do. Everybody with me? So that is optional. Section 10.2. I will have a question in the bonus section on the test from 10.2. I will have no questions from 10.2 in the normal part of the test. That would be really evil if I just said it's extra credit. Otherwise, I'm done. I'm spent. That's all I got. Everybody got a practice test, right? So I have the answer. Oh,
Mostly chapter 9.
what's up?
Mostly chapter 9.
So remember, what's going to be on this next test? Definitely chapter 9 and chapter 8. So all confidence interval stuff, all hypothesis test stuff.
So chapter 10 is then.
Bonus.
Only could be in the bonus since I made it extra credit. It could be a question in the bonus. Or it will be a question.